Day 4, 4 airplanes flying. This is all about pressure and air pressure. Pressure is pretty interesting. Pressure has to do with force over area. But you can't have an airplane unless you have air. So let's talk about air just for a second. Air is a gas that's all around us. And we have the press of air, or air pressure. Now, Indianapolis is 751 feet above sea level. But scientists like to measure air pressure in pounds per square inch. And so at sea level. So this is what's called an atmosphere bar. This is 14.6 pounds. And this represents how much air is from the sea up to outer space, about 50 miles plus or minus. And all that air, which is made of matter, takes up space and has mass, is pressing on us all the time. Some days, if you're a teacher, Fridays has a lot more air pressure. So this pressure, we don't feel it because it's pushing on all parts of us. Now, scientists have studied this, and one of my favorite, which you need to learn more about, is Daniel Bernoulli. He was one of the Bernoullis, 122 genius, a whole family of geniuses, and he worked out what we call today the Bernoulli principle. If we can get a gas or air to constrict, get smaller, two things happen. Number one, its velocity goes up and its pressure goes down. So there's a couple things we can do with this. For example, here is, I like to call this a Bernoulli bag. It's a long bag. Wonder how many breaths it'll take me to fill it up. Let's see. There's one, and not much. But if I use Bernoulli and his principle, we hang this right here in our tree, and now I'm going to step back and I will inflate this, or attempt to inflate this, using the Bernoulli principle. So I'm going to hold back and I'm going to shoot air, constrict it, make it go velocity, and use the sky to fill it in and see if this works. Ready? Not bad with a little blow and with a little bit of science of Bernoulli. Now he also did things like this. If we can, you can understand if I get this air going right here, straight up, the ball will go straight up. That makes sense. But if I get enough velocity of air, the pressure, I should be able to lower this all the way down. Let's see what happens. Ready? Here we go. And now see if I can tilt it. That's pretty cool. Of course, gravity always takes over. Another fun thing to do, well, if you have any of this extra laying around the house, is if we increase the airflow over this, much like an airplane wing, we can cause lower pressure, and this should go up. Let's see what happens. Ready? Pretty cool, Bernoulli principle. All that air stacked above us has pressure, air pressure, like this mat right here. If I drop it down, now it's got all the air, 14 pounds per square inch. And if I lift up, I can almost lift the table up with it. That's a lot of pressure. And we need that pressure if an airplane is going to fly. An airplane like this FPG-9. It flies in the air.
As many of you know, if you've taken part in the summer safari, we are lucky enough to go tour the Indianapolis airport. In there, we get to see the big planes fly. But the other thing that's kind of fun is to try the FPG-9, and so 4 planes a-flying.
Since this is a day all about pressure and being under pressure, pressure has to do with force divided by the unit of area. So if I had a nail like right here in this cantaloupe, dropping this cantaloupe on this nail makes it a very bad day for the cantaloupe. So that's because all that force was in a real small area. But what if I drop that cantaloupe on a bed of nails? Oh, better yet, What if I lay on a bed of nails and drop a weight and break a brick? Let's try it. As you can see, I'm laying on a bed of nails, and I'm hoping that all that force is going to be spread across all these nails. Let me lift this mass up. I think that might be high enough, 35 pounds. Protect my face, and let's see what happens. Pressure, force over area. 3, 2, 1. I survived the impact. Am I filled with holes? Let's find out. No holes. I think I'll stick to 4 airplanes flying.